Okay, question 4. We've got to draw a line from the object to its description. So we've got a nail with a current carrying wire. So we have made an electromagnet, and electromagnets are temporary magnets because when you turn off the current, it's no longer magnetic. So we want that to go to a temporary magnet because we can turn it on and off. A plotting compass needle. So that's a little needle that we've, say, stroked with a magnet and lined up all the magnetic domains, and now it is a permanent magnet. So it'll actually point to the North Pole of Earth, which is actually the South Pole of a magnet. So that one's going to be a permanent magnet, and a wooden ruler, just not magnetic at all, so non-magnetic. The next one, we've got a current is passing through a wire, and we've got to draw the magnetic field. So we know that these are going to be circular, and said draw them close together and then one far apart. Only ever draw 3 lines, don't draw loads of them. Then you have to use the right hand grip rule, which you've got here. You can see I've taken it and turned it upside down. So, and we can see our fingers are going that way. So that means that it's going this way around. So we use our 4 other fingers, line your thumb up which way it goes. So now I'm going to draw it on here, circle, circle. Oh, that one's rubbish. Bigger circle, and then line it up there, and then the arrows. So the marks are for the circles getting further apart as we go through. There's less magnetic flux density here, so the field is weaker, and we know that field is 1 over d squared. So double the distance, it goes down by 1/4, and then there's 1 mark for getting the arrows. Okay, next question. We've got a student measures the strength of the magnetic field in milliteslas. So if I had to do a calculation on it, I'd need to divide that by 1,000. Don't know whether we'll need to. Distance from the wire in centimetres here. You can see I've already got some lines ready because we're going to have to read those in a bit. And it said, here are some extra results. Plot the results, draw a curve. So there's the first one. 1 is 8.1. So each of these are going up in 0.2. So I've got it in between the 2 lines. 2 is 3.9. There we go. Draw yourself a curve. It says use the graph to calculate the change when it goes from 4 to 8. So you can see I've just highlighted, there's my change, 4 to 8. And then we're going to have to read off here, there, and there. See, they've made it nice and easy for us. We've got the number 2 and the number 1. So the change is 2 take away 1 is a change of 1 millitesla. And it says the distance from the wire affects the strength of the magnetic field. Give one other factor that affects the strength of the magnetic field. So clearly the size of the current that we put through the wire. And there we go, that's that question done.